All right, let's get started. Math 1, this is Unit 6, Worksheet 6.4, Mr. Trutna, Clovis High School Cougars. Okay, so we'll start it off with the joke right here. So the joke of the day is, I used to have a job collecting leaves. If you want to know the punchline, stick around till the end of the video. You'll get it. Okay. All right, so here's Worksheet 6.4. What we're going to be doing is, we're going to be, number 1, we're going to be making a scatter plot of the data. Okay, so you were not given a piece of graph paper, but I'm going to go ahead and I'm going to, right here, I'm going to take this piece of graph paper just so it's a little bit easier to see as we do it, and I'm going to make a scatter plot of this data here. So remember, when we make a scatter plot, what we do is we always draw we're going to have two axes. So we're going to draw a vertical axis, which is the axis that goes up and down, and then we're going to have a horizontal axis, which is the axis that goes left to right or side to side. Okay? And when we draw a scatter plot, if all the numbers are positive, if all the data that we're going to do, that we're going to put on the scatter plot is positive values, then we only have to put what would be quadrant 1. Okay, if we're given the data in a table, the first row, which is adult tickets, that will be represented by the horizontal axis, or what would be the x-axis, and then the vertical axis would be the second row, which would be children's tickets here. All right, so what we're doing here is we are using this table. We're comparing how many adult tickets were sold to how many children's tickets were sold. Okay, now we're going to put our intervals here, our interval lines, and we're going to make intervals for our adult tickets. So you can see our adult tickets are going by tens. So that's easy. So when I do my interval here, I'm just going to set this up, and I'm going to go every other interval is going to be worth 10. So really I'm going by 5s, but I'll just spread it out a little bit here. So I only have to go up to 50. That's my maximum number of tickets sold for adults. And then for my children's tickets sold, you can see my maximum is 137. So when I make my interval, I definitely don't want to go by ones. That would just be a ridiculous thing to do. I would have to have 137 intervals. All right, probably 5s is not even a very good idea. So if I went by 10s, let's see, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. Yeah, so I just wanted to make sure I had enough room if I scaled my scatter plot by 10s. Okay, now how you decide to scale your scatter plot is completely up to you. There's really not a right or a wrong way to do it. You just want to be smart on how you set up your scatter plot. Okay, all right, so now what we do is we treat each one of these points, each one of these pairs of numbers like 10 and 30, 2 and 55 and so on, as an ordered pair, and we plot them on our graph. So I'm going to have 10 adult tickets, 30 children's tickets. Put a point. When there's 20 adult tickets, there were 55 children's tickets. I'm going to estimate where 55 is, halfway between 50 and 60. When there were 30 adult tickets sold, there were 80 children's tickets sold, so I can get that exactly right there. When there were 40 adult tickets sold, there were 112 children's tickets sold, which is just a little bit above 110. We're going to estimate where 112 is. And then when there were 50 adult tickets sold, there were 137 children's tickets sold. Okay, so this is my scatter plot right here. So number 1, when it said make a scatter plot of the data, this is my scatter plot. Now remember, a scatter plot is pretty much going to be points. They're going to be on a graph, and then you most likely will not be able to connect them all with a straight line. Okay, that's why they're considered scattered. Okay, so we're going to be referring back to that. Now, number 2 said draw the line of best fit for the data. Okay, so this right here is my scatter plot. I'm going to draw the line of best fit. So what I do is I get out a straight edge, and then I try to draw the line that best represents the data. And when I draw the line, I probably am not going to be able to fit all the points on the line. I want to fit at least 2. I need at least 2 points on the line. And then there should be probably the same amount of points above and below the line as I do my data. So that right there is probably a pretty good representation of my line of best fit. You can see I have this point right here on the line, and that point is the data for 20 and 55. I think it was 20 and 55, yep. So that is 20 and 55, and then this point up here is the data for 50 and 137. Okay, I'm going to need that for what's coming up here. You can see I have 1 point that's below the line barely, and I have 2 points that are barely above the line. So that probably is a pretty good line of best fit. All right, number 3 then says write an equation for the line of best fit. Okay, all right, so in order to write an equation, it's going to be a two-step process. The first step is I'm going to find the slope. So I'm going to use the slope formula, which is y2 minus y1 over x2 minus x1. Okay, and then I'm going to use the 2 points, these 2 points right here and their values to help me find slope. 137 is going to be my y2 value minus my y1 value is going to be 55. And then I'm going to go over x2 value is going to be 50. And then I'm going to go minus my x1 value, which is 20. And then I'm just going to simplify this out. 137 minus 55 is 82. 50 minus 20 is 30. And when I divide this out, I'm going to get a decimal, and that's okay. And my decimal is 2.7. About. It's 2.7333333, but I'm going to say that my slope is 2.7. Okay, so that's my m. M stands for slope. Now, my second thing when I write the equation is I take my point slope form of the equation of a line, which is y minus y sub 1 equals m, then times parentheses or quantity x minus x sub 1. Okay, and now remember when I am using this formula here, in the place of y1, m, and x1, I'm going to input in values. Okay, I'm going to use the same values that I did for my slope formula. And I'm going to leave everything else that I didn't highlight as is. So I get y minus y1, we said was 55. That's equal to m, we said was 2.7. Then parentheses, x minus x1, right here, we said was 20. So plugging in those values, I get that equation. Okay, this right here is going to be my equation for the line. Remember, this right here is what we call, the point slope. Okay, equation of a line. All right, so that's the equation that I'm going to use. Okay, now I'm going to take this 27 and I'm going to distribute. I'm just going to simplify this equation out. So I get y minus 55 is equal to 27x minus 540. I'm going to add 55 to both sides of the equation. And when I'm done here, I'm going to have my equation of my line. And it's going to be y equals 27x and then negative 540 plus 55 is negative 485, so we're going to write minus 485. There's my equation for my line of best fit. Okay, so there's my line of best fit right there. My equation is y equals 27x minus 485. Okay, so that's how we go about finding an equation. Right there, there's my equation for that line. All right, number 4 says, does the data show a positive or negative correlation? Well, you can see when I did my line of best fit, the line is going up. It has a positive slope, so this is a positive correlation. So number 4 is a positive correlation, okay? So that means that as the number of adult tickets, as more adult tickets are sold, more children's tickets were going to be sold as well. That's the correlation that we have. Okay, and then number 5, it says if 60 adults bought tickets, how many children's tickets would you expect to sell? Okay, so what we do is we take our equation for our line of best fit right here, which is y equals 27x minus 485, and then I'm going to take this 60, which is the adult tickets. The adult tickets represent your x axis, and we're going to substitute 60 in the place of the x. So we're going to get y equals 27 multiplied by 60 minus 485. And then I'm going to work this out. I'm going to evaluate this, and whatever the answer is, that's how many children's tickets I would expect to sell. Children's tickets is your y-axis. So 27 times 60 is 1,620 minus 485. We get 1,135. So if we sold 60 adult tickets, whoops, somebody should have caught that. That's a 2.7, not a 27. So we're going to go 2.7. I was looking at that going, whoa, that seems like a lot of tickets there. So we're going to go 2.7 times 60. That's 162. And then we're going to multiply 162 minus 450. Okay, so then minus 450, and we would get 288. So we would expect to sell 288 tickets there. Okay, so that's how we would work out that problem there for my slope. Okay, that's a 2.7 here. My slope is 2.7. Okay, oh, I see what's going on. So that'd be a 54 there. So when I went minus 54 plus 55, this is actually a plus 1. So that means my equation is a plus 1 when I put the equation in. Okay, what a mess this is. All right, so now let's work this out again. So I'm going to have plus 1. So now when I put this in here, I'm going to get 2.7 times 60. That's 162, and then I'm going to go plus 1. So I would expect to sell 163 tickets is how many children's tickets I would expect to sell there. Okay, all right, moving on to the next problem here. Hopefully we don't have as many issues with this problem. Number 6, it says during 1 month at a local deli, the amount of ham sold decreased as the number of turkeys sold increased. Is this an example of positive correlation, negative correlation, or no correlation? So if you look here, we are going, all right, so we have ham decreased as turkey sold increased. Okay? So if we were to graph this right here, and maybe if we sketched a quick graph of this, we would have ham here, and then we would have turkey here. So as ham got smaller, turkey got bigger. So it would kind of look like this. So the more ham we sold, the less turkey we sold. So you can see this is a negative correlation. Okay? So that's what we would get for number 6. In number 7, the problem says in each of the following situations, is there likely to be correlation? And then, if so, does the correlation imply causation? That causation is a really weird word. So first of all, we first want to see, is there likely to be correlation? And then we're going to say, if correlation occurs, is there causation? So the cost of a family's vacation and the size of their house, okay? So does it correlate that people who spend, let's say, more money on a vacation, do they have a larger house? Or people who spend less money on a vacation, do they have a smaller house? I would say that this right here is likely to have correlation, okay? People who spend more money on their vacation probably have a larger house. They have more money to spend, okay? So there is correlation. And then Then we want to determine, does it imply causation? Now, causation means does one of these affect the other one? And I would say this does affect. The family vacation, cost of it, and the size of the house, they are affected. Okay? In part B, the time spent exercising and the number of calories burned. There is definitely a correlation between this right here. Okay? All right, so there is a correlation, and now causation means does one of them affect the other one? So when one of them goes up, does the other one go up? Or when one of them goes down, does the other one go down? So if I spend more time exercising, do I burn more calories? Absolutely. If I spend less time exercising, do I burn less calories? Absolutely. So that's what causation is. If when one of them goes up, the other one also goes up. Or when one goes down, does the other one go down? Okay, see, the amount of time you study for a test and the score you receive. Is there a correlation there? I would say absolutely. Okay, so there is a correlation right there. Now, we think, is there causation? In other words, if I study more, if the amount of time I study is more, am I likely to get a score that is better? Versus if I study less, would I get a score that is less? I would say yes. So there is causation in this problem here. A person's height and the number of letters in the person's name. Okay, so is there correlation here? So a person's height. So if like you're short, are you going to have a lot of letters in your name? Or not a lot of letters in your name? I say no. So I would say D, a person's height and how many letters in their name, there is no correlation whatsoever. Okay, Shaq, 4 letters. Guy's super tall. Okay, so we've got that right there. All right, numbers 8 through 11, last problems. We're determining whether the points in each scatter plot have a positive correlation, a negative correlation, or no correlation, and then we're going to estimate a correlation coefficient that is most accurate. Now, this correlation coefficient, that is what we call the R-score. And we talked about an R-score in class. So, number 8, you can see the plots that are pointed, they're going in an upwards manner, okay? So I would say that this, number 8, has a positive correlation. All right, why is it positive? Well, the points are going up, okay? And then, since it has a positive correlation, what would its R-score be? Well, it can't be negative, because a negative R-score means that we're having a negative correlation. And then we want to determine which one is this, okay? Now remember, the closer that, so if an R-score of 1 means that you have points that are basically perfectly on a straight line. And then the closer the points are to being on a straight line for the line of best fit, the R-score is closer to 1. So, would you say, I would say that these points right here probably have an R-score of 0.8. If I drew a line of best fit, maybe like that right there, all of those points are pretty close to that line. That number is further away from 1, which means the points would be more spread out. Okay? Okay, we get to number 9, and I would say that this has a negative correlation. You can kind of see the points are going down, so I would say this is indeed a negative correlation, and then I need to figure out what is the correlation coefficient. In other words, what is the R-score? Well, if it's negative, that means the R-score cannot be positive, so I eliminate those two, and then if you kind of picture a line of best fit maybe going like that, you can see these points are pretty far away from the line. So I would say the R-score is probably going to be that number right there. Okay, that means the points get more and more spread out, further and further away from -1. Okay, number 10, the points are all over the place, so I would say that there is no correlation in number 10. All right, so then what is the R-score here? Well, if there's no correlation, it means that your R-score is equal to 0. Okay, and the last one, you can see the points are going down, so this means we have a negative correlation going on. And then, what's the R-score in number 11? or what's the correlation coefficient? Well, it's negative, and if I kind of drew a line of best fit here, are those points pretty close to the line? Absolutely they are. So I want to pick an R-score number pretty close to -1. -1 would mean all the points are on the line. So I'm going to pick negative, and let's go ahead and go with 8. Okay? If you said -0.9, that'd be okay. If you said -0.7, that'd be okay. All right? So we're done. So let's go back. I used to have a job collecting leaves. I was raking it in. There we go. Okay? There's your joke of the day. Use it to wow somebody. All right, so have a great day, and remember, math is not a mistake. See ya.